Hello, my class 9 students. This is the solved final examination paper of chemistry of class 9 ICSE syllabus. This is the paper of the final examination of one of the reputed schools. It's a very good paper. If you want to revise for your chemistry, I think it's a good idea to just solve this on your own. Pause the video whenever you want and check up with the solutions that I am showing you so that you can get your full marks in chemistry of pre-boards class 9 ICSE. As you know, our section 1 has 40 marks. And in those 40 marks, you will have question 1 with each subpart for 5 marks, as you can see. And then we'll have section 2, which will be again of 40 marks. There you'll have a choice of questions. You will have to attempt 4 questions, each one having 10 marks. Now, question number 1A is for fill in the blanks. Now, for this, when you write the answer, you will write the answer just like question number 1. You will say A, and the first one you will just write the answer to this. So the molecular formula of ammonium sulfate is either this or this. Now you need to know your valencies well. So if we are talking about ammonium, it is NH4 radical. Now NH4 has valency 1 plus. Let us say you forgot the valency of ammonium radical, then just remember any compound of NH4. So if you have NH4Cl, then you know that Cl has 1 minus. So if we have to have formula like NH4Cl, then NH4 must be having 1 plus valency. So that is how we decide the valency for the ammonium radical. And sulfate. Now you know the sulfate valency. If you have forgotten, just remember something like H2SO4. Where did this 2 come from? It came from here. So SO4 is 2 minus. Once you know that this is 2 minus, when you do crisscross, it becomes NH4 twice SO4. So this is the option. So we will write NH4 twice SO4. So we present our answers like so. The second one, group 2 metals are called as not alkali, they will be alkaline earth, because alkali means group 1A or 1, and this is group 2 or it will be group 2A. So group 2 metals, they are called as alkaline earth metals. We come to the third one. If an element has 2 electrons in its outermost shell, then it is likely to be a metal or a non-metal. Now the element has 2 electrons. Now remember, the elements with 1, 2, 3 valence electrons become metals. So this is definitely a metallic. We come to the fourth one. The temperature is called absolute zero. Now absolute zero is this temperature. You know this very well. Very simple question this was. We come to the fifth subpart, the maximum number of electrons that can be present in the M shell of an atom. Now M shell, remember your first shell is K shell, then L and then M, which means M is your third shell. Third shell will have the formula with 2n square giving us 2 into 3 square, which means 2 into 9, which is 18 electrons. So our answer is 18 electrons. So that finishes our first 5 marks. Now you can gauge yourself how much are you scoring per subpart of each question. Okay, so here if you got 5 full marks or you went wrong somewhere here, then if it is one question that you lost mark, just give yourself 4 marks. If you got all of these right, give yourself 5. If you got 2 right, write over there 2. And understand how to write the answers the correct way. Let us come to 1B. Choose the correct answers from the option given below, the symbol of nitrate. Now nitrate is NO3, nitrite is NO2, and nitride is just N. Nitrate is valency 1 minus, NO2 is valency 1 minus, and nitrite is valency 3 minus. Remember, this one with most oxygen ends in 8, so it will be nitrate. This one with lesser oxygen than this, it ends in ITE, remember that. And if we have only nitrogen, then it ends in IDE. Okay, so nitrate will be A. So we will have B, first one, the symbol is going to be NO3 1 minus. The second one, isotope of hydrogen without a neutron. Now let us see, our protium is hydrogen 1 1, our deuterium is hydrogen 2 1, your tritium is hydrogen 3 1. Now this is your thinking step. The hydrogen without a neutron is going to be the one which has only a proton. Now this one is the atomic number. This means that there is just one proton, and that proton is reflecting here in the mass number. Look at this. This is again one proton. So this 2, which is mass number, has one proton and one neutron. For tritium, this is one proton, and this number 3, which is atomic mass, it is one proton and 2 neutron. So once you realize this, you will see this has a neutron, this has a neutron, this one is without the neutron. So your correct answer is hydrogen 1 1, which is protium. So we will write over here A, which is protium. This one also is A. Let us come to the third one. A trivalent anion of an element contains 10 electrons. The atomic number of this element is. Now trivalent anion, if it is an anion, it has gained, trivalent means 3 electrons, which means now it has got 10 electrons. These 10 electrons are something that it had from before, plus it had gained 3 electrons. Now what plus 3 gives us 10? It will be 7. So because it had 7, it has now gained 3 electrons, and because of that it's got 10 electrons, and so we'll have 7 as the option B. So it will be B and it will be 7. Number 4. 1 dm cube of gas is equal to, now must remember that 1 dm cube is 1 liter. How much is 1 liter? Is it 1 ml, 100 ml, 1000 ml? It is 1000 ml. So here it will be C, and that is 1000 ml. Getting it right? Let's move to the fifth subpart here. The metal above hydrogen in the activity series, and it does not react with water. Now activity series above hydrogen. So above hydrogen we have Pb, below hydrogen we have Cu, then we have, these ones are below. Now it is above hydrogen but does not react with water. Now copper is below here, so we cannot take. Hg is below H, so we cannot take this, and the only one which is above H is Pb. So fifth one is B, which is Pb. Let us come to name the gas evolved in each of the following cases. Number 1, zinc reacts with potassium hydroxide solution. Now remember, zinc along with Al and Pb, it shows amphoteric nature. So amphoteric nature with acid liberates hydrogen. Now can you see this hydroxide means it is OH, hydroxyl group. So zinc will, even with alkali, liberate hydrogen. So here it will be hydrogen. Sodium sulfite is reacting with dilute sulfuric acid. Now the property of dilute acid, whether it is sulfuric acid or nitric acid or hydrochloric acid, remember sulfide is SO3 2 minus. So it is going to produce sulfur dioxide. We have ammonium chloride reacting with calcium hydroxide. Now here it is better to show the reaction for your thinking. Ammonium chloride is NH4Cl and plus calcium hydroxide is CaOH twice. And if we do this double decomposition, we will have Ca taking Cl, it will become CaCl2. So we will need 2 over here to balance this Cl. Now 2 NH4 and 2 OH will give us 2 NH4 OHs, but remember your NH4 OH is actually this. Your HOH is water and this is your NH4. So you see, whenever there is NH4OH, we have to write water and we have to write ammonia. So NH3 and H2O is NH4OH as I have shown you here. Okay, so we will have 2 of NH4OH, so 2 H2O, 2 NH3. So we have here, for this the gas evolved is ammonia. Thermal decomposition of mercuric oxide, it is going to give you oxygen. Calcium carbonate reacts with dilute hydrochloric acid. Again, any carbonate with any dilute acid will, because it is CO3 2 minus radical here, it will give carbon dioxide. So CO2 will be liberated. So we say carbon dioxide. So that is how we answer the question like this. The next one is your question 1b. Write the chemical equations for the following chemical reactions. Aluminium to sodium aluminate. Now aluminium plus something you will have to add, and you need to get sodium aluminate, that is NaAlO2. Now aluminium gives a complex salt with alkali, because again aluminium, just like how I told you, zinc, lead and aluminium, these are going to be amphoteric in nature. So they are going to, with alkali, they are going to give us a complex salt. So we have Al plus the alkali will have to be with sodium here. So we will write NaOH, and remember aluminium needs dilution of that alkali. So we will have this giving us NaAlO2, that is sodium aluminate, and it is going to liberate H2. And you have to remember this reaction using the coefficients like this. So this is our first reaction. Then we have the second one, hydrogen gas combines with nitrogen to form ammonia. So here we have hydrogen plus nitrogen, and it is going to give us 2 NH3. So balanced reaction is like this. Now remember to write, there are 4 conditions. We'll have finely divided iron as the catalyst, promoter is molybdenum, temperature is 450 to 500 degrees C, and the pressure is 200 to 900 atmosphere, and plus it has 22,400 calories heat evolved, so it's an exothermic reaction. Thermal decomposition of ferric hydroxide. Now ferric hydroxide is FeOH thrice, and when you are heating it, it is going to give us, because there are 3 OHs, we will get 3 H2O, and in addition to that, remember, if there are 3 H2O, there are 3 H and OHs. Now 3 OHs are here, so we will need again another 3 OHs by putting 2 over here. So we will have Fe2O3 formed over here. Balancing it out, just check 2 Fe here, 2 Fe here. How many O's do you see? 3 2's 6. 6 O's are there. So can you see over here? This is O3 and this is O3. So there are 6 O's. And how many hydrogens do you see over here? 3 2's 6. Can you see that? So this is the balanced equation for this. Now, chlorine reacts with hydrogen to form hydrogen chloride. So we will have H2 plus Cl2, and that will give us 2HCl. For the reactions which have conditions, you must write the conditions. Here you have to write diffuse sunlight, and here it will be moisture. So that is the condition you have to write in your answers. Phosphorus burns in the oxygen to form phosphorus pentoxide. Now phosphorus is P, oxygen is O2, and it is going to give P2O5. Now remember, oxygen here is odd number, but whenever we are burning something, we will always have some O2, which means O has to be even number. So let's make this even like this. So how many phosphorus atoms we see here? 4. So we balance this phosphorus. Now look at this oxygen. How many oxygens do you see here? 2 5s 10. So it will be 5O2, and that will give us 2P2O5, and it's balanced. Now we come to the next one, relevant observation. You have to be very careful for the relevant observations. Copper nitrate is heated. Not just copper nitrate, but all nitrates. You must know those by heart. Copper nitrate is heated. You will have copper nitrate, which is blue in color. It is going to become CuO, which is black, and it's going to liberate NO2 gas. So we will say reddish brown. NO2 gas is evolved, and blue copper nitrate, let me just write the formula straight off, becomes black CuO. Now solid ammonium chloride is heated. Now here solid ammonium chloride is going to turn into gaseous mixture. So we'll say it turns into a mixture of two gases. Okay, so it does not melt, but it turns into a mixture of two gases. So it turns gaseous vapor state. And why that is so? Because it's a sublimable solid. Washing soda crystals are exposed in atmosphere. Now if they are exposed to atmosphere, what will happen to washing soda? It is an efflorescent substance, so it's going to lose water of crystallization, and so the washing soda crystal will be coated with anhydrous sodium carbonate. So we will write over there, it gets coated with white anhydrous sodium carbonate layer. We come to pentahydrated copper sulfate crystals. Pentahydrated means water of crystallization. There are 5 molecules. Now when you heat, these water of crystallization molecules will be evaporated. They will be becoming vapor, and so we will have blue hydrated copper sulfate crystals become white anhydrous amorphous copper sulfate. Dilute sulfuric acid is added to zinc sulfide. Now here this zinc sulfide is ZnS, and dilute acid is going to provide H, which will combine with this S and give us H2S. What do you know about H2S? It is colorless. H2S gas means hydrogen sulfide gas with smell of rotten eggs is evolved. We come to question 1F. Match column A with column B. A has chlorine. Now chlorine is green in color, it is acidic, it bleaches, and maybe, yes, greenish yellow. Can you see that? So here chlorine is F. Sulfur dioxide. Sulfur dioxide will be it turns the lime water milky, yes, but it will be smelling of sulfur. This is more appropriate, so this will be C. Carbon dioxide, it turns lime water milky, so it is A. Hydrogen burns with pop sound, so that is our E. And nitrogen dioxide is reddish brown, and that is our B. Okay, so this was easy. I hope all of you got full marks for this subpart. Give reasons for the following. Gases diffuse rapidly. Now, why do they diffuse rapidly? Because they have large intermolecular spaces between them. So it becomes easier for them to get diffused. Isotopes have different physical properties. Now, isotopes have different physical properties because they have different number of neutrons. Okay, which means they have different atomic mass. So the physical properties will be different. Granulated zinc is preferred to metallic zinc in the preparation of hydrogen using dilute acid. So remember, granulated zinc is the commercial zinc. So we will write it is commercial zinc containing impurities which have catalyzing effect on the reaction. So the yield of hydrogen is better. Number 4. Atomic mass of sulfur is a whole number, but that of chlorine is not. Now we have to remember that chlorine has two isotopes, that is Cl 3517 and Cl 3717 present in the air in the ratio 3:1. Now because of this, what happens? Therefore, the average atomic weight is going to be 35 into 3, because every 3 atoms is going to be from this source, plus one of them will be here, so that will be 1 into 37, and that upon 4. So out of every 4, 3 will be this and 1 will be this. So that will give us here 105 plus 37, that upon 4, so that will be 142 upon 4, which is 71 upon 2, which is 35.5. Okay, so the average weight is a fraction. So hence average weight is a fraction for chlorine. But in case of sulfur, that is not so. Okay, so sulfur has quite a few isotopes, so it is irrelevant for it. Actually, this question should not have been given along with sulfur like that, because our syllabus does not talk about sulfur and isotopes. Okay, now fifth one, metals form positive ions. Here what will be a first key point? Metals have how many valence electrons? 1, 2 or 3 valence electrons. Correct? Therefore, they lose 1, 2 or 3 electrons to attain stable electronic configuration of the nearest noble gas. And become positive ions as in the ions the number of protons is more than number of electrons. Remember, if they are losing the electrons, then the electrons are less and protons are more. Okay, state the type of reaction. Now here the first one is like A plus B gives AB, so this is direct combination or synthesis. The second one, you will see that aluminium is above copper in the EC series, so aluminium displaces copper and takes the place of copper, so this is your displacement reaction. Then PbO2 is splitting into two common components, so this is your thermal decomposition. Then we have next one here. Can you see? It has become BaSO4, which is a precipitate plus 2 HCl. So this is your double decomposition. Reaction. And this one over here, the last one, this is a base. Why it's a base? Because it's got this hydroxyl group, and HCl, you know, is the acid, and it is giving us here salt, and this is water. So this is your neutralization reaction. So that finishes our section 1. Section 2 has to be attempted from section 2 we have to attempt any 4 questions. So Let us quickly look at our questions. I'll be solving all. You have to solve any 4. Answer the following. An atom of an element is represented as X3919. So it will have this atomic number is equal to 19, and therefore the electronic configuration is going to be 2881. Write the electronic configuration of X. So our A answer will be 2881. Our B part. What does the value 19 indicate? It is the atomic number. So we will say it is the atomic number. Then we come to the next one. State the valence electrons in the element X. Now valence electrons, how many are there? 1. So it will be 1. And write in words also. Now we come to the second part of this is the first part. Now we come to the second part of this question 5. State the type of bonding that is present in the following molecules. Now your A is sodium chloride. Now sodium is from group 1A and chlorine is from group 7A or 17. So you will see that this is a metal which will lose electron, and that electron will be gained by chlorine, and so it will be electrovalent compound. Now we come to B, water. Now water, is HOH. So if you look at the structure, where shall I draw the structure? Here. So if this is oxygen, this is 1, 2, 3, 4, 5 and 6, and this is HH. So this is your H2O, this is your water. Can you see that? Yeah. Now this shared pair will be attracted more towards oxygen, and so because oxygen has 8 protons, it will have slightly negative charge, and each one of these hydrogens will have slightly positive charge. So you will see it's a covalent compound because these electron pairs over here, these are shared anyway. But you will see that there is polarity also developed. So your B will be polar covalent bond. Your C is methane. Now methane will have carbon single bond H, single bond H, single bond H and single bond H. So this becomes a covalent compound, but you will see that the electron pairs are pulled more towards carbon, but they are equally pulled. They are equally shared, and so there will be no polarity. So because there is no polarity, it becomes a non-polar bond. So non-polar covalent bond. Now write the formulae in the following compounds by crisscross method. So we have copper oxide. Copper oxide, your A of the third part. Copper oxide, it is copper 1 oxide. So Cu has +1 valency, oxygen has -2 valency, and so by crisscross you will get Cu2O. B, sodium chlorate. Now what is sodium chlorate? Sodium is Na. Na is 1+. Chlorate is ClO3. That is again 1-. Now crisscross will give us NaClO3. Then we come to C, aluminium oxide. Now Al is 3+ and O is 2-. So crisscross will give us Al2O3. We come to the last one, which is D, it is iron 3 nitrate. So iron 3 means Fe3 plus and nitrate is NO3 1 minus. So crisscross will give us Fe with 1 and it will have NO3, it will be thrice. Okay, so these are our answers for question number 2. We now come to question number 3. The first part says give the valency and the formulae for the following radicals. Now we come to acetate. Acetate comes from acetic acid. Now what is acetic acid? Acetic acid is CH3COOH. So when it dissociates, it will have H1 plus and this one is the acetate radical. So question 3, first part, your A will have acetate group will be CH3COO1 minus. Now this is the formula and then the valency is going to be 1 minus. So we will write the valency is going to be 1 minus. We come to B, bisulfite. Bisulfite is HSO3 1 minus. So this is your formula and the valency is minus 1. Let us come to the third one. Draw the orbit structure for the formation of the following. Nitrogen molecule. Now nitrogen is atomic number 7, therefore electronic configuration is 2, 5. So it has to share 3 electrons. So we can have your A part. This is the second part. A will have nitrogen. Nitrogen will be the first, will be your 2 and the second one will be your 1, 2, 3 and 4 and 5. And another nitrogen will be like so. This will be the first orbit will have 2 and the second one will have 5. So we will show the second orbit like this and we'll show 1, 2, 3 here and 4 and 5. So that becomes your nitrogen, triple bond nitrogen, because it has got 3 shared pairs like this. Then we have calcium oxide. Now calcium oxide is CaO. So calcium has electronic configuration, it is 2882 and oxygen has electronic configuration 2, 6. So for our calcium oxide, calcium will have here 2, then 8, then again 8, and then again 2. So these 2 electrons will be given to oxygen and oxygen will have the first shell having 2 electrons and the second shell having 1, 2, 3, 4, 5 and 6, and then it accepts 2 electrons from calcium and so it becomes calcium 2 plus because 2 electrons are less, plus it will have oxygen which has taken 2 electrons, so it will be 2 minus and that will give us CaO as the structure. So our C part is talking about ammonia. Now for ammonia, nitrogen is 7, which is 2, 5, and we have hydrogen, which is 1. So we will start with nitrogen. Nitrogen will have 1, 2, and then in the second orbit we will have 1 here, 1 here, 1 here, and these two over here. So we have 5 electrons, and this will be shared with hydrogen like so. Okay, like this. Now when we show the orbit, we are going to show nitrogen with these 2 electrons and these electrons over here, but here it will be having orbital with hydrogen with 1 electron of nitrogen and 1 of hydrogen, and the same thing will be here as well. This will be this hydrogen with its electron here. The same thing will happen here this side also. There will be 1 more hydrogen forming this bond here. So this will be with 1 more hydrogen, and that will be H over here. So that is how it becomes nitrogen with single bond H, single bond H, single bond H, and the lone pair of electrons here. Now here for nitrogen, this is where the lone pair of electrons will be, this one here and this one. Okay, so that is your ammonia. Now they are talking about distinguish between the precipitate reaction and neutralization reaction, and electrovalent and covalent bond. This is 1 mark each. Now in precipitation reaction, we have 2 soluble salts react to form an insoluble substance. But for neutralization, we will say an acid reacts with a base forming salt and water. We have the next one, which is this is your A, this is your B, electrovalent and covalent bond. So basically you could just write the definition of this: formed by transfer of electrons from a metal to a non-metal. And covalent bond is formed due to sharing of electrons between 2 non-metals. Okay, now state the law of octaves. You can do this on your own. This is a straightforward question. Now let us look at the next question. This is question number 4. Complete the following table. Now remember, the idea is you have to choose the questions which are easier for you to solve, easier for you to score marks. So if you think a particular question is difficult, just leave that question. Okay, and in this we have element, so you will have to copy this table and then you'll have to write aluminium 27, 13, and these are all blanks, and boron is 11 and this is 6, and these other ones are blanks. So if aluminium has mass number 27, mass number means proton plus neutron. Atomic number is only the proton. So the number of electrons will be the same as protons. They will be 13 here. Number of protons will be the same as atomic number. That will be 13 here. But number of neutrons, if P plus N is 27 and P is 13, then N will be 27 minus 13. So number of neutrons is going to be A minus Z, which is mass number minus atomic number. So it will be 27 minus 13, which is 14. Boron has mass number 11 and it has number of neutrons as 6. So if protons plus neutrons is 11 and our neutrons are 6, so the number of protons are going to be 11 minus 6, which will be 5. So the atomic number also will be 5 and the number of protons also will be 5, and we completed this. Now the second part of question number 4, ZCl2 is the chloride of a metal Z. Write down the formula of its sulfate, hydroxide and nitrate. Now this is an important question. If it is ZCl2, so I will write over here ZCl2, that means this 2 has come from Z. So Z is 2 plus and Z is 1, so chlorine is 1 minus. So valency wise Z is 2 plus and chlorine is 1 minus. Okay, keeping that in mind, now we are writing number 1, sulfate. So if we have to write the sulfate, we will write Z2 plus as we got here, and plus sulfate is SO4 2 minus here. So crisscross will give us, therefore it will be ZSO4. So this will be the formula of the sulfate. Next one, the second one over here is hydroxide. So hydroxide will be, now I'll write Z2 plus and I will write OH1 minus. So crisscross will give us Z and OH will be 2 in number, so ZOH twice. And the third one, they are saying the nitrate. Nitrate will be, we'll write Z2 plus here and we will write NO3 1 minus here. When we do crisscross, it becomes ZNO3 twice. Okay, define the group in a periodic table. Learn it straight from the textbook. Yeah. Now we come to question number 5. A gas occupies the initial volume of 400 centimeter cube at pressure Z. If the pressure is changed to 5 atmosphere, the volume of the gas was found to be 200 centimeter cube. Calculate the value of Z. Now can you see the pressure is changed? So did they change the temperature? No. If they didn't change the temperature, then we will say question 5 first part, with temperature remaining the same, we will have P1, V1. So we will write first of all the case 1 and case 2. If we have initial volume, that means V1 is equal to 400 centimeter cube and the pressure P1 is going to be Z atmosphere and the V2 is 200 centimeter cube and our P2 is 5 atmosphere. And so temperature should be the same. They have not mentioned it. So it is going to be by Boyle's law. we'll have P1 V1 is equal to P2 V2. So it will be Z multiplied by 400 is equal to 5 atmosphere multiplied by 200. So we will have Z equal to 5 atmosphere into 200 divided by 400. Cancel the zeros, 2 ones, 2 twos. So this comes out to be 5 upon 2 means 2.5 atmosphere. Okay. Then define modern periodic law. Again, you have to learn this on your own, so learn it up. We'll come to the third part. Atomic number of the element is 16. So immediately first thing you have to know is 286, which is the electronic configuration. A part says state the period and the group it belongs to. So question 5, third part, we will say it will be period 3, and right over there, since it has 3 shells. See here, there are 3 shells. And how many groups and which group it belongs to? It is 6 over here. So it will be group 16 or 6A. Okay, so this is your A part of third part of 5. Now we come to number of valence electrons of the element. So valence electron, how many valence electrons? It is 286. So this is 6. This is your answer. Then we come to C part. Is it a metal or a non-metal? So 286 it is. Now 6 means if it is 1, 2, 3, then it's a metal. But 6 means it's a non-metal. So we will have non-metal. And what is the reason for that? Since 6 valence electron. Okay. Now we come to how will you distinguish between zinc 2 plus and lead 2 plus using NaOH solution. Now whenever they give you a question like this, you will have to make the columns. So the first column is going to be the test, and here it is going to be Zn2 plus, and here it will be Pb2 plus. And they say use NaOH, so we will say add NaOH little and then in excess. So zinc is going to give gelatinous white PPT. So if we say if gelatinous white precipitate, I'll just write PPT, which is soluble in excess, then Zn2 plus present. But if it is Pb, you will not get gelatinous white. We will have if chalky white precipitate, which dissolves in excess, then Pb2 plus present. Okay, so this is the format in which you have to show the distinction. Name a solution which absorbs the impurity H2S in the laboratory preparation of hydrogen. So this is our 5th subpart. Remember, in the preparation of hydrogen, there are quite a few washer bottles which are going to absorb the impurities. So we have H2S is absorbed by lead nitrate solution. Remember each washer bottle and the function of it. This is question number 6. First part, name the following group of elements. So we have to name the group. The elements are short by 1 electron in the octet. 1 electron short means they must be having 7 electrons in the valence shell. So they are going to be halogens. Highly reactive metals with valency 1. Valency 1 means it will have 1 valence electron. So they are going to be alkali metals. Non-reactive elements will be the one which are noble gases. That is group 0. Elements with 2 electrons in the outermost orbit. 2 electrons in the outermost will be group 2A. 2A means it will be alkali earth metals. Give the formula for the following: Glauber salt, green vitriol, blue vitriol. What is Glauber salt? It is sodium sulfate. So it is Na2SO4 dot 10H2O. It has water of crystallization. Green vitriol is FeSO4 dot 7H2O. And blue vitriol is CuSO4 dot 5H2O. State and explain Charles' law. Write Charles' law equation. Learn this up. All this is directly just learnt up from the textbook. Charles' law equation will be V1 upon T1 equal to V2 upon T2. Define solubility. Again, this is the learning work which you can do on your own. Balance the following chemical equations also you can do on your own. Not a problem. Calculate the mass percentage composition of copper in copper sulfate. Now here, question number 7, we will have the second part. We first have to find out the molecular weight of CuSO4. So that will be copper means it will be 1 and multiplied by 64, that is 64, plus sulfur will be 32, plus oxygen will be 4 into 16, so that will be 64 plus 32 and plus 64 is 64. So you have 128, 130, 160. So 160 is the molecular weight. And now we have to find out mass percentage composition of copper. So we will say percentage composition of copper will be equal to, if we want copper, then we should write mass of copper upon the total mass, means the mass of CuSO4, correct? Multiply that by 100. So you will have mass of copper. How much copper is here? 64. Total mass is 160 multiplied by 100%. Okay, so that is how you will get this. 16 ones and 16 fours. So mass of copper, so percentage of copper is 40%. Okay, so that is your answer for the second one. Fill in the blanks. This is the last question of this paper. On moving from left to right in a period, the number of electron shells. Now left to right, it will be the same period. So number of electron shells will be the same. They will remain the same. So this is the correct option. The number of valence electrons. What will happen to valence electrons? They will become 1, 2, 3, 4, 5, 6, going up to 7. So they will be increasing, yes. So they will be increasing by 1 each time. And the elements show transition from blah to blah. Now it will be transition from, it will be metallic to non-metallic. Okay, so now that we understood this is metallic and non-metallic, this was the last question. Now I know that the finals are approaching closer. I hope you have understood everything, and I wish you all the best for your examination. Study well, stay safe, stay healthy. Bye.